Welcome to another session of INF154. So in this session, we are going to focus on decision making. So this is your if statements and your switch statements. So in this video, we are not going to cover like we are not going to do like those if statements, whatnot. We are going to cover Boolean expressions. So when it comes to decision making, to solve some problems, we must make decisions based on the test for true false condition. So if the condition is true, we need to execute a set of statements, and if it's false, we need to execute another set of statements, or we need to execute like no statements. This process is known as selection, where like to determine if we have to execute a particular set of statements or not. This process is known as selection. So before we can get into relational expressions, let's recap Boolean variables. I guess from now you realize that you haven't used Boolean variables so much so far. So a Boolean variable is a variable that only stores true or false. So it only stores either a true or a false and nothing else. So in Boolean algebra or digital design, 0 represents false and 1 represents true. So everything in life comes in Booleans. So it comes into relational and equality expressions. To make decisions, we either use relational or equality expressions. So the summary of those expressions is that for relational expressions, we have less, which is represented by this less, then we have less or equals to, which is represented by this symbol, then we have greater than, which is represented by this symbol, then we have greater or equals to, which is represented by this symbol. So for the equality, we have the equal, which is represented by this, then we have not equal, which is represented by this. So these relational expressions or operators have the highest precedence compared to the equality operators. So now we can dive into those expressions in details, or into those operators in detail. So we are going to start with the relational operators. So for the rational operators, we have less than, which is represented by this angular bracket. So A less than B, the result is true if and only if A is less than B. So if A is less than B, this thing is true, as we know from maths. Otherwise, the result is false. So we are going to look at a few examples. So for example, let's say I have result equals to 3 less than 4. So we know that 3 is less than 4, like from mathematics. So is 3 less than 4? Yes, it's true. So we are going to store true inside the variable result, or res. So another example, we have int a equals to 10, int b equals to 20. So in memory, we have this a, which is 10, then we have this b, which is 20. So bool result equals to b less than a. So we know that this thing means is b less than a. If b is less than this, it's less than a, it's going to return true, otherwise it's going to return false. So our b in this case is 20 and our a is 10. So 20 is not less than 10. So this is no. So in result, we are going to store false. This expression evaluated to false. So another case, we have int a equals to 10, then b equals to 10, then we declared this bool result equals to a less than b. Then we have to ask ourselves, is A less than B? No, A is equals to B, so this thing is false. So we are going to store false inside result. Then another operator is less or equals to, which is represented by this angular bracket and an equal sign. So for less or equals to, this returns true if A is less. It's either A is less or A is equals to B. Then examples, we have int A equals, A equals to 10, B equals to 20. We know that in memory A is going to be represented like this. It's a variable that stores 10. Then B is a variable that stores 20. Then we have bool result equals to A less or equals to B. In this case, I was supposed to say B, but it's fine. So result equals to A less or equals to 20. So my A is 10. Is 10 less or equals to 20? 10 is less than 20. So this expression is true. So we are going to store true inside result. Then I have another variables, int A equals to 20 and B equals to 20. Then I say result equals to A less or equals to B. Then we have to ask ourselves, it's A less or equals to B. A is equals to B. So this less or equals to, it first evaluates if A is less than B. So in this case, 20 is not less than 20. So it's going to evaluate again. It's A equals to B. Yes, 20 equals to 20. So the result is true. So another example, we have this form. So we have A, which we get from our text box, then B also from a text box, then we have this button submit. So we want to demonstrate the less or equals to. Then inside A I stored 10, then inside this text box I stored 5. So I know that I have to declare my variables and get the inputs from the form. So int A equals to, then txt_a.text is a string. Then on my left I have an integer. So a string and an integer don't match. I have to convert that txt_a.text to an int so that this assignment operator can work. Same with B, I get my B from the form. So at the end, A is going to store 10 and B is going to store 20. So I have bool result equals to A less or equals to B. So I have to ask myself, it's A less or equals to B. In this case, my A is 10. So is 10 less or equals to, and I made a mistake. My A is 10, my B is 5. So in this case, it's A less or equals to B. So it's 10 less or equals to 5. No, 10 is greater than 5. So the result will be false. So that was just a mistake. Then we have greater than. So for greater than will return true if A is greater than B. So it returns true if A is greater than B. Otherwise, it returns false. So examples, let's say you have int A equals to 10, B equals to 30. We know that in memory, A is represented by 10. A stores 10, then B stores 30. Then result equals to A greater than B. Our A is 10. Then our B is 30. It's 10 greater than 30. No. So the result will be false. Every time you say no, the result is false. Every time you say yes, the result is true. So let's say we have int A equals to 10, B equals to 10. Then in memory, we know that A stores 10, B stores 10. Then I say bool result equals to A greater than B. So I ask myself, is A greater than B? Is 10, which is A greater than B, which is 10? No, they are equal. So the result is false. I said no, so my result must be false. Then let's say I have int A equals to 20, B equals to 50. So in memory, I have this A which stores 20, and I have this B which stores 15. So I ask myself, before I have bool result equals to A greater than B, then I have to ask myself, is A greater than B? My A is 20, then my B it's 15. So is 20 greater than 15? Yes. So I said yes, my result will store truth. Then we have greater or equals to. So greater or equals to returns true if A is greater than or equals to B, otherwise it returns false. Then examples again, we have int age equals to 17. Then we know that in memory age stores 17. Then we have a constant int old equals to 18. So I have bool is old equals to age greater or equals to old. So my age is 17, then my old is 18. Then I ask myself, is 17 greater than or equals to 18? No, 17 is less than 18 and it's not even equals to 18. So my result will be false. Let's say I change age to 18. Then I know that in memory I'm going to throw away the 17, then my 18 will come inside this box. Then I ask myself, I have this, is old equals to age greater or equals to old? Then my age is 18, is 18 greater than or equals to old? My old is also 18, so 18 is equals to 18, so the result will be true. Then let's say age is equals to 100. Then I say is old equals to age greater or equals to old? Is 100 greater or equals to 18? Yes, 100 is greater than 18. So the result will be true. Then we consider the equality operators. So for the equality operators, we have the equal to. Note for the equal to, we use double equals to because we already used a single equal to for assignment operator. So the assignment operator is the one that we use to store values inside variables. So if I say A equals to B, now it's a comparison operator. So it compares A and B. If they are equal, it returns true, otherwise it returns false. So if A and B are equal, it returns true, otherwise it returns false. For example, int A is equals to B. This is an assignment operator, it's not a comparison operator. Then B equals to 10, assignment, C equals to 20. Then in memory, we know they are represented like that. Then I say bool result equals to A equals to B. So I'm comparing A and B. Are they equal? So in this case, my A is 10, my B is 10. So they are equal. So the result will be true. So it's a yes. The result will be true. Then I have my result again equals to A is equals to C. Then I compare A and C. Then since they are not equal, 10 is not equals to 20. So it's a no. So I'm going to store false. Then we have not equals to. So it's A not equals to B. This we say this is a not. In programming we call it a not. This I forgot the name, but it's just a not. So equals to B. Compares A and B. It returns true if A is not equals to B. So it's the opposite of equal to. So otherwise it returns false. For example, let's say we have int A equals to 1, then we have our B which is equals to 2, C equals to 2. Then I say bool result equals to A not equals to B. So I have to compare 1. A is 1 is not equals to 2. Yes, A is not equals to 2. So it's a yes. So it's going to be a true. Then at the later stage, I say result equals to B not equals to C. Then result my B is 2 not equals to C, which is 2. Then I ask myself, is 2 not equals to 2? That's false. They are equal. So I'm going to store false. Then now we are ready to move to if statements. So we have one-way selection. So the if statement on its own. So for the if statement on its own, you test a condition. So if that condition is true, you are going to execute a certain set of statements or a certain set of instructions. So you have this if, then you open this bracket, then inside here you put your condition, then you put these curly brackets, in between you write your code. So if this condition is true, we are going to execute this only if this condition that we put inside these two brackets is true. That's when we are going to execute this expression. So for example, let's say we have our int a equals to 10, then our b is equals to 20. So we are going to say, okay, if, then we open a bracket, then our condition goes inside. So if a is greater than b, we are going to say message box.show, then this is just basic string concatenation, a is greater than b. So let's evaluate this. So to execute an if statement, you have to say, okay, my a is 10. So is 10 greater than b? My b is 20. Is 10 greater than 20? No, 10 is not greater than 20. So I can't execute this because my condition here is false. I said no here, so it's false. I can't execute this. So this is an error. So this semicolon was not supposed to be here. This is just an error, but I'm not supposed to execute this because 10 is not greater than. If my a was 20, my b was 20, my b was 10, I was going to say, is 20 greater than 10? Yes, 20 is greater than 10, so I'm going to execute this. We only execute the code in between these brackets only if this condition is true. So this condition can be more complicated. It's normally not as easy as this, but we'll get into if statements in detail. That's why I didn't start by doing if statements. You have to understand those basic expressions. Then, oh, I didn't finish executing. So for this one, a equals to 10, b equals to 20. So I have this a which is 10. We know that 10 is not greater than 20. So this message, this whatever it's in between, it's not going to be executed. Now my code continues. lst items.add a plus b. This code is going to be executed. Any code that follows after these two brackets, it's not affected by the condition. Whether this condition is true or false, this code is not affected by this because it's not in between these two brackets. But we will get into if statements in more details. So yeah, that's it.